Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. You're here with Adi, bringing you the second episode in this bonus webinar mini-series, where we're going to focus on the concept of map projections, why we need them, and how we can fool Tableau into using something different than its default setting. In the last episode, I took you through some of the theory of projections, but really focused on accessing reprojected geojson base maps to manipulate Tableau for disease mapping purposes. Now, you'll get along just fine today without having seen that episode, but it is linked on the screen here, so give that a click if you'd like to go and watch it now. If you are staying with us, today we're changing gear a little, reversing out of the how-to and rolling along with the what of map projections. Before we get into the details, I'm delighted to have Ellie Mason along for the ride. Say hi to the folks at home, Ellie.
Hello.
Ellie is a colleague of mine, a data school consultant, and a fellow spatial specialist, having studied geography and then meteorology at university. Now I'm going to pull up on here a super cool visualization that Ellie made, and we're going to discuss this in just a few moments. But before we get on to that, Ellie, can you tell us a bit more about your employment history before data school?
Sure. So my first job after my master's was working for the Met Office up in Aberdeen, helping to provide forecasts for ships and oil rigs in the North Sea, before I moved to London to work in market research, which was more data and report based.
Okay. And what stage did you join the Information Lab's data school?
I joined in late 2018, so I've been there for about a year and a half.
Okay, so it sounds like you've come to the data school with quite an impressive geographical background, and perhaps with the Met Office, it does sound a bit like you've used some GIS before. So would it be fair to say that you already knew about map projections, or did you have to educate yourself before doing this viz that we're looking at on the screen?
So it is safe to say I knew a bit about projections, having studied GIS as part of my course at university, and then using softwares like ArcGIS, both at university and at the Met Office. But I definitely had to educate or re-educate myself for the specifics of my use case for Antarctica. I could see the viz in my head, but I needed the right projection to allow me to actually visualize it, visualize the South Pole in Tableau.
Okay, gotcha. So you had the right kind of background appreciation of what was going on. You put yourself in a position to solve the challenge that you had, which was actually to make that a reality in this visualization. And for the folks at home, if we break this down, and Ellie, jump in if I've got this wrong, we're looking at, as viewers, at Antarctica as if we're in a satellite or an airplane flying directly over the South Pole. Is that right?
Yep, that's right. And you've got your iceberg routes going kind of clockwise around Antarctica.
Okay, so these are sort of these strands of different colored, what looks like the best hairstyle ever, sort of drifting around the continent of Antarctica. And if I bring up Google Earth, it's going to be a bit more clear how we get to an orientation like that. So effectively what we're trying to do, or what Ellie has done in that visualization, is to reorientate the view. So in Google Earth, I have this 3D version of Earth, and I can spin it east to west. I can also spin it north-south. And it's this north-south orientation that Ellie's gone for in that visualization. It's something almost exactly like this, where we've just got sort of South America drifting in at the edge of the view. And this is pretty easy to do in Google Earth with a few drags, a few clicks. And unfortunately, it isn't possible just to drag the view around in Tableau in the same way that we can do in Google Earth. And that's because we're taking this 3D geoid, this spherical Earth, and trying to flatten it out to view in 2D. And that's really the crux of this idea of coordinate reference systems and map projections. taking a 3D object and trying to manipulate it in such a way that it fits a 2D view. Now, Ellie knows much more about this. So what I'm going to do now, Ellie, is get you to take over the screen and give us a little bit more depth on map projections, if you would.
Yeah, of course. So, what are map projections? In cartography, a map projection is a way, as Adi said, to flatten a globe surface onto a flat surface in order to make a map. This requires the transformation of the location's latitudes and longitudes from this globe shape onto a flat surface. This was discovered by Leonhard Euler in 1777. Every map projection, because of this transformation of the latitudes and longitudes, includes some certain distortion. So map projection theory primarily deals with researching map projection and just looking into how these are described mathematically. Depending on the purpose of the map, some distortions are acceptable and others are not. So therefore, different map projections exist in order to preserve some properties of the sphere-like body, this geoid, at the expense of other properties. So therefore, each map projection distorts in a distinct way for a distinct purpose. So therefore, cartographers and users of maps should apply the projection according to the properties or conditions that they want to look at. An example of this is the Webb-Mercator map. His map of the world uses cylindrical conformal projection. It's rectangular in shape and preserves angles across the map. His main use for creating this projection was for navigation, marine navigation. So therefore, what was up on the map was also north in actual real life. Allows the user to plot these straight lines, giving them a bearing and an actual sense of direction, allowing for specific routes to be followed or just generally to knowing your way around. But it grotesquely exaggerates the northern and southern high latitudes and warps the size of the places relative to one another. But despite this weird view of the world, i.e. I'll show you in a second with Greenland being quite large, it's become the default view of the world and is presented almost as a square, a rectangle, and it's become the view of the world that we see most often on school walls, in media, and on the web. This is because the conformality of all of the lines, the fact that north is up and south is below, means that you can zoom in to a map at large scales, which is perfect for web browsing. So therefore, if you truncate the north and south poles of the world at 85 degrees, you then get this square shape that then seems like it kind of works with all of the angles. So wherever you are on the map, as I said, up is due north, down due south, and east and west are always right and left. However, it means that there's a lot of distortion happening. So this is an example here, and I'll show you in a second on a different website. But you can see that this plane is the same shape. This is what it looks like on like the geoid we talked about earlier. And this is how all of the different kind of projections work across the world using Mercator. So if I then take a look at this website, and there's two examples I'm going to show you that actually display this in kind of a more graphical way. Let's take a look at Greenland. You'd think, looking at this map, that Greenland, over here, is the same size as Africa. So let's just talk about what this map is for a second. This map is the Webb-Mercator. It's zoomable, I can zoom in, I can zoom out, and it looks like the maps we're used to seeing. However, you'll see that at the poles, everything is greatly enlarged. So if we take this overlaid here, this is Greenland. So the total size is 2 million square miles. If I then move this over Africa, so at the moment it looks like they're the same size, but what I'm going to do is move this over Africa and we get to see the actual size of Greenland versus Africa. So on the Webb-Mercator, they look the same size, and yet when you actually overlay the actual size of the country or over the continent, it just doesn't compare at all. So the information that we have in the Webb-Mercator greatly enlarges Greenland. Another example of...
Hold on, Ellie, one second. We're looking at Greenland, so we've just moved this down to the equator, right?
Yeah.
and we go, okay, it's gone from being the entire size of the continent of Africa to just about the same size or just slightly bigger than the DRC, the Democratic Republic of Congo, just right in the center.
Yeah.
And this is purely as a result of this web Mercator strategy.
Exactly that. Exactly.
That, man, I mean, I knew this already, but my mind is blown. This is a great website.
It's an amazing website.
Yeah. Do you have another example that you can show us?
So another example is Russia. So you'd think here Russia takes up kind of triple the size of Greenland, all the way over here. So if we then go Russia and click Russia, we can see it extends quite far, goes quite far north. However, again, let's use the example of Africa, because that's quite near the equator and a good size to compare it to, especially with Greenland there. We can see that if I then bring this down to the north of Africa, it just about covers the northern half of the continent of Africa. What looks like it's one of the biggest areas is actually only kind of half of Africa.
Now, I must confess to the viewers at home, I have seen this with Greenland, but this is the first time I've seen this done with Russia. That is incredible. How pronounced Russia is in a web Mercator, like a default Tableau map, and it's really just the top end of the continent of Africa. That's incredible. I keep interrupting you because this is so good. Sorry, Ellie, keep going.
That's all right. It's a really fun website. So you can play around with all sorts of things and find out what happens. The best ones are, as we've said, at the polar regions. So you've got your Greenland, even Canada. Let's type in Canada. Let's go for it.
Yeah, let's do
all
that.
the polar regions. So we've got Canada here. Again, it looks quite big, but if we then bring it over, sort of over here for size, it also fits in North Africa, and yet when we move it back over here, back up to where it was, it looks kind of the same sort of length as Greenland, the same length as South Africa, Africa, and yet it too is not as big as it would be presumed to be. So
wow.
Yeah, that's some fun projection stuff for you there.
Wow. Yeah, that is incredible.
So Tableau actually uses Web Mercator as its default processes. This is because of the processes going on behind the scenes. It will always project your data as a Web Mercator. And Web Mercator is not just the case that the projections look different, it's actually distorting the information. So as we saw with Greenland and Russia, it's actually distorting that area and allowing the user to think that it's larger than it was. This is especially the case for the spread of disease, and therefore can make it inappropriate for certain things.
Yeah, so it is important to come back around to that idea of responsible disease mapping. So coronavirus, COVID-19 really is on all of our minds just now, and we put a spotlight on that in the first episode of this mini-series. If you haven't watched it, the crux of the issue that Ellie's just been talking about is also captured by someone called Kenneth Field. He's a cartographer who works out in Redlands in California at Esri, which is one of the world's leading proprietary GIS providers. But he's really championed this cause publicly, relentlessly pointing out issues with published maps and producing a blog detailing the pitfalls of disease mapping and the solutions. Now, there's a link to that blog in the description of this video, but Kenneth Field's core message is this: that for any map of population data, not just the COVID-19 data, any map of population data, for that map to work, we have to use an equal area projection. Web Mercator won't support the map's purpose because these distortions that Ellie's just showed you will lead us to over or underestimate the size of areas relative to one another. And that has the effect of propagating people's impressions of less or more in terms of quantity because of the over or under exaggeration of parts of the map. And that's simply due to the projection. For us talking about Tableau, what we're saying here is that purely by the default display in Tableau, we're not giving our viewers the best opportunity to gain the greatest insight into the data. But we also know that Tableau is flexible and we can often bend it to our will. In the first episode of this mini-series, I give you the hookup on a totally free, open source online tool that anyone can use to download sample data or reproject their own data. And that's the Dirty Reprojectors tool from the folks over at Development Seed. Like most other things we point you to, it's linked in the description box below this video. In this series though, we also want to take you through the actual methodology of that reprojection process so you can understand what's happening under the hood and also how to troubleshoot. We're going to do that first in Alteryx as one of our software partners, but also in QGIS for those people who don't have access to Alteryx, or those of you who want to learn a bit of desktop GIS. And with that, I'm going to say thanks to Ellie for being here today and taking us through the nitty-gritty of map projections. Thank you, Ellie.
No problem. Thanks for having me. I'm always happy to chat about maps.
Yeah, it's been great to have you. That true size, it's an incredible thing. And you're going to be back with us next time for the how-to guide, aren't you?
Yep, I'll be taking you through how to change projections in QGIS and a little bit of Mapbox as well.
Mapbox magic, that's going to be marvelous. We'll both hope to catch you all next time. Until then, keep exploring and feel free to reach out to us here at the Information Lab for solutions to your data challenges.
To stay up to date with all our YouTube content, hit the bell icon to subscribe to our channel.
Stay safe, and we'll see you all soon.